Today, we are going to find all of the roots of a polynomial given one of the imaginary roots using synthetic division. So since I give you 3 plus I as a root, we are going to put 3 plus I in the corner. When you look at the polynomial that's given, we are not missing any terms because it goes from the x to the fourth to x to the third to x squared to x to the constant. So we're just going to write down our coefficients and we are going to spread them out a little bit. So 1, -6, 6, 24, and -40. Leave a space and draw a line. The first step is to bring down the 1. To get back up over the line, you multiply by the corner. So 1 times 3 plus I is 3 plus I. To get back down, you add. If you take -6 plus 3, you get -3. And you cannot add the I to it, so just plus I. To get back up, you again multiply by the corner, but this is a binomial times a binomial, so you would probably want to do that off on the side. -3 plus I times 3 plus I. And you get -9 minus 3I plus 3I plus I squared. The middle two terms subtract out. I squared is -1. So -9 minus 1 is -10. So after we multiply, we put that number up over the line. To get back down, you add. So 6 plus -10 is -4. To get back up over the line, you multiply. Again, off on the side, I would multiply these. -4 times 3 plus I. And you get -12 minus 4I. To get back down, you add. 24 plus -12 is 12, and you still have a -4i. To get back up, you multiply. 12 minus 4i times 3 plus I, and you get 36 plus 12i minus 12i minus 4i squared. The middle terms subtract out again. A -4i squared is really -4 times -1, so it's a +4. 36 plus 4 is 40. And you add. Now, we know from the remainder theorem that that better be a 0 because I told you 3 plus I is a root. If you don't get a 0 at this point, don't keep going because you got to go back and change something. If we are told that 3 plus I is a root, that has to be a 0. All right, I'm going to erase this work was off on the side so that we have room. Okay, we started off with x to the fourth. Now we are down to an x to the third with imaginary coefficients. And we don't really want to factor an x to the third polynomial with imaginary coefficients. And they didn't give us another root. But we know that imaginary roots come in conjugate pairs. Since they gave us 3 plus I, we automatically know that 3 minus I is a root because it's the conjugate. Whenever you have imaginary roots, their conjugates are also roots. So we can now put 3 minus I in the corner and do this again with the depressed equation. So we'll bring down that 1 again. 1 times 3 minus I is 3 minus I. The second time around always goes a little bit easier. -3 plus 3 is 0. I plus -I is 0, so we get 0. Well, to get back up, you multiply. So 0 times anything is 0. To get back down, you add. -4 plus 0 is -4. To get back up, you multiply. If you take -4 times the quantity 3 minus I, you get -12 and then plus 4i because you are distributing that. and you get negative 12 plus 4i. When you add those together, you get 0. Again, you should always get 0 because it's the conjugate. Okay? So at the beginning, we had an x to the fourth. The first depressed equation was an x to the third. Now you have an x squared. So now we have the depressed equation x squared plus 0x minus 4. And we want to find the other roots. So we're setting this polynomial equal to 0. And we're either going to factor it or use the quadratic formula. Well, we can factor this one. X and x, 2 and 2, plus and minus. So x plus 2 equals 0, and x minus 2 equals 0. Our last two roots are negative 2 and 2. The first two roots are 3 plus I and 3 minus I. Those are our 4 roots, and we know there were 4 answers because it was an x to the fourth power.